I want to talk to you today about a subject that, as Alexander said a few years ago, I'm a kind of a nerd, okay? I'm a medical doctor, but I was, as a child, interested in science fiction. I did a lot of work in molecular biology, cell biology, and I'm interested just generally in science, and particularly in biological sciences. And I have been since I was a small child. And this transhumanism theme, when it arrived, that probably about 10 years ago, it seemed to me to be a bit of a curiosity, something on the margins that some people were involved in. And I remember there's an Austrian scientist, his name is Hans Moravec. He lives now in the United States, and he wrote a book I think about 15 years ago, called I, Robot, which I read, and I found the ideas intriguing, but a little bit strange, and I just became interested in it from that point of view. And as time has progressed, and particularly in the period we're in right now, okay, we can see that this transhumanism movement is not some kind of fantasy. It's not just the stuff of films. It's actually something that they are trying to implement right now, okay? And we heard this morning about Islam last night. A lot of these different fields now, what we are realizing right now is that they're coming together. And the transhumanist philosophy is actually not transhuman, it's anti-human, okay? And I just want to introduce you to two aspects of that and show you a little bit of information so that when you read about this in the newspapers or wherever, that you can have an idea what is meant by it, okay? And I've called this talk, Optimized Dream, or is it a disappointing nightmare? This is the question I want to pose this morning. And I wrote, for those of you who speak German, I wrote an article on transhumanism. It was published in the magazine Cato, October 2019. And a lot of the ideas that are in the talk are also in this article if you want to read it. And the first idea is that humans have always wanted to transgress the borders of their own corporeality, of the body that we're born in, the limitations that we have, okay? This is a very old cultural meme, if you like. The word we'd use today is meme, okay? And this, for example, this statue you see here is the lion man of Höhlensteinstadel, okay? That's an artifact. It's made out of ivory from the tusk of a mammoth, the mammoth elephant. It's about 25,000 years old, 25,000 years old, okay? This artifact was found, it derives from the time when humans first appeared in Europe. And it's at the start of what's called the Old Stone Age, okay, Alte Steinzeit. So this is one of the very first artifacts that we have that humans made. And what you can see is it's a man with the head of a lion, okay? So from the very start of civilization, this idea of mixing humans with other creatures, let's say, has been a dominant theme. And what you can see here is the chimera of Arezzo. That's about 2,500 years old. It's a lion, the head of a lion, the body of a goat, and the tail, if you can see, is a snake, okay? So we've three different animals, or there we have from Greece, Theseus and the Minotaur, okay, Minotaurus, so this idea of mixing one species with another species is very old. It's as old as we are as a species, if you like, okay? And it also had a big mythical significance. And I want to just, unfortunately now, I'm going to get a bit hardcore molecular biology. I'm sorry, you just have to put up with it, okay? So the first concept I want to introduce you to is the concept of, they're called cybrids, okay? What's a cybrid? For about the last 50 years, say, molecular biologists and cell biologists have been working on this concept. This is what is done in this experiment is you have a fertilized egg cell, okay, which is on the left. You can see it here, a single cell nuclear transfer. So you take the egg cell, let's say of a sheep, and you fertilize it in vitro. And when the egg cell is fertilized, the program for division is switched on, okay? So this cell is then activated. And in the cytoplasm, which is the cell fluid, if you like, all of the various mechanisms, molecular mechanisms are there. And then what you do then is you remove the nucleus of the fertilized cell, and you take then a nucleus from another cell of another animal. Let's say a skin cell. Doesn't really matter. And you take this nucleus, you could have one person, you have the fertilized egg cell, you remove the nucleus, and then you take what's called a somatic from a body, we have two types of tissue in our body. We've called germ tissue, which are the ovaries and testes, which are part of the reproductive system and everything else, okay? So that's called somatic tissue. So you take a somatic nucleus, put it into a previously enucleated, fertilized egg cell, okay? And then what you have is a mixture. So you have the DNA, the nuclear DNA is from one animal, and in our cells we have little bodies called mitochondria, which are like little factories in the cell, but they have their own DNA. So you right there you have a mixture of two different animals. So the mitochondrial DNA comes from the one animal and the nuclear DNA from another animal. And that's called a cybrid. And we have a lot of different interspecies mixtures that are produced by this and other technologies. They already exist, okay? It's not science fiction. So if you, for example, one animal is called a chimera. What's a chimera? A chimera is you have two different embryos. So you have in this particular instance a sheep embryo and a goat embryo. And then what you do is you separate the cells of the two embryos and mix them up together. And then you get an animal which is comprised of two distinct cell populations from two separate species. Okay? So in German this is called Schiege. I call it Schot in English. So it's a mixture of goat and sheep. Okay? That's called a chimera. The next one is you have a hybrid. So a hybrid, well, that's something we know. It's where the cell of one species is, the egg cell of one species is fertilized by the sperm cell of another species. So, for example, a Maultier, a mule. A mule is a mixture of an ass and a horse, a mare. But mules are not fertile. Two mules cannot reproduce. It stops at that point. Okay, so that's a hybrid. The cybrids I've already spoken about. That's where you take the cell body of one cell and the nucleus of another from another animal. And then you have transgenic animals. Transgenic animals are where you just introduced separate genes, just not the entire nucleus, but just little bits of DNA. Those are called transgenic animals. Or here you have for example, the clone shaft, the clone sheep, Dolly, very famous a few years ago. Dolly is actually a cybrid, okay? And the idea is then once you have this technology, of course, you can clone it, you can produce many, many different copies of the same animal, in effect. And when this came out, there was a debate, of course, the first time this came out, and immediately, this is a newspaper article from 2008. So 2008 in this kind of technology is ancient history, okay? It's already a generation ago almost, scientifically speaking. But in 2008, this was debated in the Parliament, and the UK Parliament more or less unanimously approved this kind of research. So there is no society as a whole sees this research as beneficial and as something that should be pursued. And these are the cybrids you can see here. This is another article. First hybrid embryos, when were they created? 2008. We now have 2022, so that's 14 years ago now. Okay, and the idea I want to just the reason I'm kind of going on about the cybrids a bit is a lot of the way ideas are introduced into societies, you start with a very small dose of the idea, okay? So people get used to it. So the cybrid is the kind of the initial dose to get you fixed, like a drug, fixed on the technology. So what they say is, well, you know, it's not that bad if you have, say, the cytoplasm of one animal and the DNA, let's say, from a human cell, because 99.9% of the DNA is in the nucleus. Only 0.1% is in the mitochondria. So it's not actually such a big difference, okay? And then you say, what we can do, you have to find a moral justification. So the moral justification in this case is we can produce humanized embryonic stem cells. So we have say a cell body from one animal, we put in the human nucleus, so we humanize that cell, and this will enable us to develop stem cells. And so, you know, you have been aware, most of you, about the stem cell controversy. If you derive embryonic stem cells, that's a big problem. So now here we are we're presenting an alternative, so we don't need to use embryonic stem cells. So this is the second step. So you say it's only very small, the step is just a tiny step. And, you know, there might be some issues with it, but the alternative stem cells are even worse, okay? And then you say there's no supply chain problems, you know, there's practically, whereas human embryos are kind of limited, you know, there's no limitation in the supply of animal ooze, egg cells, animal embryos. They are practically unlimited in terms of their supply. And then the next thing you do is you say, you promise heaven and earth, you know, this can be used to treat, for example, to cure diabetes mellitus, to cure Alzheimer's disease, to cure people with blindness, macular degeneration, to cure people with spinal cord injuries. So there's a whole lot of cure even perhaps Alzheimer's disease. So you take a lot of very serious conditions and you say, well, this technology will help us to solve these medical conditions. And the corollary of that is, if you oppose this kind of technology, well, obviously, you know, you don't care about the people with Alzheimer's disease. You don't care that people are going to be stuck in wheelchairs for the rest of their lives, because otherwise you would want that. Okay, so to me, this cybrid technology, using cybrids, it's not something that most people are aware of, but it's one of these. It's an area where you can see this stepwise approach to getting us used to an idea. Okay, so you promise a lot, you put a moral value on it, you say it's only a very small step, and it prevents it's to the greater good, because the alternative would be even worse. And this is how the technology gets introduced into society. So what you see here is a timeline of this kind of technology where in the production of human-animal chimeras. Okay, I showed you the newspaper article. So it started off 2007, where at the University of Newcastle in the United Kingdom, a group proposed creating a mixture of human and bovine cow embryonic cells. Okay, so they wanted to make a bovine human cybrid. 2007. There was a big debate. So this is actually also an interesting, what you do then is, if you want to introduce it, you don't go through the regulatory procedure, okay? You just do the experiment secretly and then publish it, right? Then, of course, there's a big debate in the newspapers. Then people say, oh, this is terrible. So then it goes up to Parliament. It gets debated in Parliament. What happens? Parliament retrospectively approves the experiments, okay? So that's exactly what happened here. So you introduce shock therapy, okay? In with the experiment, out into the newspapers, big thing, it's not too bad, okay? So that was 2008. And then the focus moved from the UK to the United States. and Japan, and a group surrounding a researcher called Nagauchi. He started then, the idea was to use this kind of technology to produce an organ of one species in a different species, okay? So he started with mice and rats, and the idea was to take embryonic stem cells from the mouse and put them in the rat, and then program them in such a way that they would turn into a pancreas. Okay, so he started. He cultivated the pancreas of a rat in a mouse embryo, but it didn't grow. The idea was then, when it was fully grown, to remove the pancreas and put it back into a rat and see what happens. Okay, so the organ was too small. It didn't work. That was 2010. But 2016, a few years later, Juan Belmonte, he's from Spain. He works in the Salk Institute in La Jolla in California. He put the gallbladder of a mouse into. He created a rat with a mouse gallbladder, and he started then producing human and human pig hybrids. Okay, so he put human embryonic stem cells into a pig embryo, and the idea was, he said, well, if we can put human embryonic stem cells into a pig embryo and program them in such a way that a human liver, let's say, will develop in the pig, well, then we can use that liver for liver transplantation. Okay, so the justification is we want to get through this block with organ transplantation, with a lack of organs, and we're going to use this technology to do this. So this was 2016. 1 year later, Nagauchi then was successful in the experiments that hadn't worked a few years before, and he was able to transplant then the pancreas into, he grew, this time he did it the other way around. He grew a mouse pancreas in a rat. Then he was able to transplant the mouse pancreas and put it into diabetic mice and cured the diabetes in the mice. Okay, so that's more or less. There's obviously been a lot of work going on since then, but you can see what's happening. We're already now in the area where we're creating a mixture of human and animal embryos. Okay, and these are not. This is not the stuff of science fiction. This is published research. You can look it up on the internet. It's funded by governments. It's funded by the European Union. There are a number of countries that are particularly heavily involved. One would be England, Israel, interestingly, the United States, of course, and then the European Union as a body is involved in funding this research. I want to show you what a chimera looks like. This is a picture from a publication from Belmonte, 2017. So this is original research. This is from the original publication in the journal Cell. Cell is probably in the field of cell biology, I would say, the most prestigious journal by far, I would say. And so this is of course right in the middle of scientific efforts, and is absolutely mainstream. Okay. And what you can see here is this is an original photograph of the mouse rat chimera. And what has been done is, in this experiment, is the cells of I think it's actually the mouse cells have been colored so that the mouse cells show up as red and the rat cells show up as white. Okay? And what you can see is, you would say in German, marmoriert. It's like marble, okay? It's marble, like the marble cake. So what you can see is these two cell populations are completely intermingled. It's not that, the idea was we only want to produce a liver, but look at that embryo, So you can see, so also particularly in the nervous system, you can see in the head of the mice. So there's no way that we don't know that if we create, say, a mouse pig embryo, and we put human embryonic cells into a pig embryo, there's no way of knowing that the nervous system, for example, of that creature will, of course, also be a mixture. And if you look at that embryo, you can see the kind of admixture that takes place. And we understand to some extent how we can program a stem cell to go in one direction or in another direction. Okay, but we don't understand that completely by any means. We don't understand completely the mechanism by which cells migrate in an embryo, all of this kind of stuff. So, but this is the work that's been going on. You can see that's the animal at 24 months. So these animals do develop and live. But the question then is, what do we have now? Is that a mouse or a rat? I don't know what it is. Yeah. So I want to. So that's the kind of the biology behind it. The cell biology. I'm sorry if it's a bit technical, but I think we need to discuss the technical issues so we know what we're talking about. Going back to a central part of all of this, of course, is the question of human dignity. Menschenwürde in German, okay? Because the question, what does a human have dignity, and why does a human have dignity? And if we go back to ancient times, right, in the ancient world, in the Antike, okay, the human being was the center of creation. And in fact, in ancient Greece, the animal was actually the being that is not a human, okay? So, or the human rather is not an animal. So the Tier and Mensch, the idea was one cannot be the other. So they're not even the opposite of each other. It's just a different entity. So why is that? Because the human has the capacity for moral thinking, and the animal does not. Okay? The human has intellect, the animal does not, in the sense. So the idea was these are not they're not just opposite, they are completely separate. Okay? Now, as time went on, that of course this view that humans are unique and different began to be eroded. I've just taken just two positions. There are many positions on this. One is Jeremy Bentham, Enlightenment, 1748, so this will be about the end of the 18th century. And he introduced a view that many people would espouse, actually, if you just read newspapers, the popular culture, what's called the pathocentric view. So the idea is an animal should be respected if it's capable of feeling pain. Okay, so this is a view that, for example, Peter Singer from Australia, the bioethicist and radical, you have to say, proponent of abortion, but also Dawkins in England, they would propose this pathocentric view, Richard Dawkins. So the idea is if a being is capable of feeling pain, particularly if it's a vertebrate, right, and so a vertebrate animal with a spinal cord, well, this creature is worthy of respect. And then Albert Schweitzer adopted the biocentric view, and he said that all of life should be respected. And humans in this view have a particular role because they are the custodians of the natural world. Okay? So our view is we're custodians of the natural world, but we're also part of the natural world and not separate or not different from it. So this is a different view from the view of the ancients, of course, the Christian view, of course, which is also completely different. But those are kind of the major view that we will encounter in our culture is either the pathocentric view or the biocentric view. The anthropocentric view is getting weaker and weaker, and is in the culture as a whole is not really it's not mehrheitsfähig. You won't get a majority for that view at the moment. So when this came out, the German Ethics Council, that's the Ethikrat, in 2011, very quickly actually, because if you remember 2008 these experiments were performed in England. 2011, very quickly, the Ethikrat, which was better then than it is now. For example, Axel Bauer was part of it. So they produced a report on this kind of technology, and they said this is problematic because the question of human dignity dignity does not just apply to the individual, but the human species as a species has dignity. And these experiments are an affront to the dignity of humans as a species, which I thought was remarkable because it's actually quite clear. And they said the generation of the dignity of humans applies not only to individual persons, but also to humanity as a whole. Human dignity is not just the individual dignity of each person, but also human dignity as a member of the human species. The generation of mixed species creatures could impinge on the dignity as a species. The creature might be unable to view itself either as a member of the human species or of the animal species. So this has effects on the entire society. Society will be uncertain how to deal with such creatures since it will be unable to assign them a clear identity. So this is a bit weak as well, because the problem is not intrinsic to what we're actually doing. The problem is how do we codify them in law, which is actually a weaker position. But that was the German position, and I want to just close that part now, because I just wanted so the one part of transhumanism, beyond human, is the dissolving the boundary between humans and animals, and producing a mixture of humans and animals. Okay, the second part I want to go into now is the increasing interaction between humans and machines. Okay, so the one thing is humans and animals, humans and machines. Okay, and I just want to show you just one small example. This is Alan Flake. He's a pediatrician in Philadelphia. And he succeeded, that's about 5 years ago now, he succeeded in producing an artificial womb. Okay, this is something that people have been working on for a long time. It proved very difficult because of problems of infection. And Alan Flake developed a system. I won't go into the technical details, but he was able to overcome these problems. Okay, so he tested his system on sheep. Okay, so this, and you can see here, is a lamb. A lamb is the 23 weeks old. That would be, I think, in human terms, about 30. I'd have to look it up. But so it's a fairly advanced lamb. Okay, but as you can see, it has no hair. Okay, there's no coat, and this is actually the lamb. Okay, 4 days in this bio bag, and so he then 4 weeks later, you can see the lamb is a lot bigger. Okay, it's grown a lot bigger, and it has grown a coat, and in fact, the lamb was able to be delivered. Okay, so the idea, Alan Flake developed this technology as a means of treating premature infants. Okay, so but like a lot of these problems, a lot of these technologies, something as a society we really need to think about the implications of it and how it can be used. So you can see here, this is from a science fiction movie where you have the babies in the incubator, and you can see we're not that far off actually from that. And the idea is to of course, immediately that came out. Immediately that came out. It was seized upon by two groups. It was seized upon on the one hand by the abortion group, the abortion activists, and they said, because immediately they saw the potential that if the child could be delivered at a very early stage, and it sort of developed in an artificial womb, well, this would be a theoretical argument against abortion, because you could say, well, there's an alternative. And they said, well, the real problem for the woman is not so much having to carry the child. The problem is the issue of reproductive autonomy. So this does not solve the problem of reproductive autonomy. So that was very interesting, because this research appeared in Cell in April. And the counter article appeared in The Spectator in England from an academic in Oxford already in May. So I don't know how they've been watching this in advance, but it was very, very interesting. So if we just think about this from a bioethical perspective, there are positive developments, okay? There are positive aspects. The positive aspects are better development and much fewer complications for premature infants. So you can actually, if this technology is developed and if it works, you can actually have a better outcome. It's an alternative to abortion for women who do not wish to give birth. And an important point is the preborn child is rendered visible. A problem that we have with children before they're, and this is why there's the big debate about ultrasound, also in the United States, because we know that once once the parents, or particularly the woman, actually sees the baby and sees that it is actually a baby, a bond is formed, or the attitudes change. So this would be in this direction. It would make the preborn child more visible. Of course, there are negative consequences as well. One of the negative consequences, it's a further decoupling of fertility from the relationship between the parents and the child, or between the parents among themselves. The control over the destiny of the child, of course, is complete. You've complete control over the child's destiny with this kind of technology. And it's in German, I would say Verfügbarkeit. So I don't know what the exact translation of that is, but the child is you can completely control the destiny of that child. It's completely verfügbar. You can do what you want with it, essentially. Interesting, JBS Haldane. JBS Haldane was one of these radical groups connected he was part of this, let's say, Darwinist movement, and he already said in 1924, he said in 2074, that's 150 years afterwards, he said more than 7 of 10 children will be born not of a mother, but by ectogenesis, and that's what he actually meant by ectogenesis. So we can see that these ideas have been around for a long time, and they're now coming to fruition. Okay. A concept I want to introduce is the concept of health. Okay, health, and we know this now for the last 2 years. Health has actually become a religion, a fetish, I would almost say. Okay, health is a fetish. And we used to think of health until recently as more or less the absence of disease. So you have a continuity. So of course the most radical disruption of health is death. Okay. Then the next is invalidity, permanent disability, then illness, and then you have health. So we only looked at the left side of that. But now health means a lot more. Health doesn't stop there. It goes on to the next step, which is optimization. And that picture you can see here is from the Transhumanist Association. I'll come back to it later. And then enhancement. Okay, enhancement. So optimization is fitness, training, doing everything you can to make yourself as healthy as you can. Enhancement is we start putting in technology to enhance the biological functions. And the end point is then immortality. And I'm not exaggerating, actually, when I say that. This is the declared end point. And you can see here, that's a picture of Ray Kurzweil. Ray Kurzweil was the technology chef in Google, now Alphabet. So this guy is not a nobody. The kind of the Postille, hätte ich gesagt auf Deutsch, the publication of the movement is more or less the magazine Wired. Any of you who are kind of computer experts will know that Wired is a big computer magazine, but they cover this topic very closely. So Ray Kurzweil, this is in Wired, live forever. Live forever, okay? And I just want to go into that a bit. So we've talked about dissolving the boundary between humans and animals. And now the boundary between humans and machines, the other side. Now this is, of course, something that has fascinated us for a long time, particularly, let's say, in popular culture, okay? So first of you know that's the Robocop. Robocop can't move very well and so on. But he gets better. And you have here the next step, of course, is the Borgs, okay, I'm probably showing my age here now. This is from Raumschiff Enterprise, Star Trek, the Star Trek franchise. So this is the next step. So you have enhanced humans, okay? So you have basically a human, but his body has been enhanced by a lot of different technologies. And the interesting thing is that the Borgs have this concept that the consciousness of the individuals is mixed in a hive mind, they call it. So the Borg is no longer an individual, he's part of a collective. He can't function as an individual. Only the Queen, the Borg Queen, has a personality. And Captain Picard, he's so important, he gets a personality too, but those are the only two with personalities, okay? And they call Captain Picard locutus because he can speak, the others can't speak. So these are ideas that are really quite powerful in the popular culture, okay? And this at the right, the bottom right is not a drawing, it's actually a photograph, okay, of a person, what's called a biomechanical tattoo. So you can see the desire that many people have to actually become part of a machine. You can see his arm here on the left, okay. A lot of the ideas were in this book, Our Molecular Future. So what is transhumanism? And this definition is partly from Wikipedia, partly from the Transhumanist Association, and it's actually quite a good definition. So what they say is transhumanist thinkers study the potential benefits and the dangers of emerging technologies that could overcome fundamental limitations, as well as the ethical limitations of using such technologies. Okay, so the way they define themselves in the public arena is their function is to look at new technologies and to see where the dangers of new technologies are and define the ethical boundaries. That's, of course, the complete opposite of what they're actually doing in real life, okay? What they're really interested in, the most common transhumanist thesis is that human beings may eventually be able to transform themselves into different beings with abilities so greatly expanded from the current conditions to merit the label of post-human beings. So the idea is not just enhancement or optimization. The idea is to create a new type of species which is completely different from us, to transcend, not just to improve, but to transcend. And this man you see here, he calls himself Nick Bostrom, but he's actually called Niklas Bostrom. He's a Swede, and he started this movement. This is their symbol, H+, and he founded in Oxford the World Transhumanist Association 2008, and he then changed it to Humanity Plus in 2004, in 1998 rather, and then 2004. So 1998. So how long is that? 30 years? Yeah. And so he published this book, 2016, Super Intelligent: Path, Strangers, Strategies. Okay. So like a lot of what we've been discussing today and what we heard last night, all of this stuff actually is in the public domain. That's the interesting part. None of this is secret. I mean, they tell us straight out what this is, and yet the importance of it is not really discussed. So this is the website. You can see here what we do, human enhancement. So we have a network, like a computer network, but the network is making a picture of a human brain. Okay, so the cortex. So you can see the idea is already. What it's really about is the central nervous system, intelligence, consciousness, and that's the end goal. And the other aspects are just intermediary steps. So what are the tools? The tools of transhumanism. If you look at what big universities or what military strategists define as the lead technologies, okay, the acronym is GRIN. Okay, GRIN. G stands for genetic engineering, okay. R stands for robotics. I stands for artificial intelligence, okay, or information technology. And N stands for nanotechnology, okay. So genetics, robotics, AI, and nanotech. Okay, those are the four elements of grin. And I just want to show you just here, for example, so the idea is the holy grail, if you like, of the transhumanist movement is to model the human brain, the human central nervous system. And there was a project, I think it was the Frontiers program of the European Union a few years ago, to map completely the human brain. Okay, the mapping project it was called. I don't know how successful it was. I think it might be still going on, but that's what it's about. And this is just one paper, more or less at random almost, to show you. So this is here, artificial neural networks created by nanophotonics. And they say it here, the construction of intelligent machines that mimic, that's biological neural networks, like us, okay? BNN is us, has been pursued since after the invention of the modern computer. Most of the research into artificial neural networks is based on software simulation using von Neumann computers. The concept of mimicking biological neural networks with electronic or photonic hardware, which is called neuromorphic computing, was introduced in the 80s. Compared with artificial neural networks based on biological neural cells, these rely on photonic systems containing artificial neurons to indirectly mimic the neurobiological architecture presented in biological neural networks. So the fundamental problem was, for a long time, the concept was the brain works like a computer. So we had the computer, von Neumann, eins und zero, also 1 and 0. Von Neumann was this enormous genius that essentially invented computing. And then after many years of fruitless research, it was realized that the central nervous system does not work like a computer at all. It works in a completely different way. So the idea is now to mimic the biological network in our brains and to try and produce, to reproduce that in a machine. Okay, and that's just an illustration from that paper. I just want to direct your view to the I here, GHI, and what you can see here is they've created by nano printing technology an artificial three-dimensional lattice, and on this lattice they are able to. The idea is to put neurons into the lattice and then connect them with nano wires to computing systems. So having been unable to model mental processes in a silicon-based computer, the idea is now to try and work out some way of getting both of these together. Okay, I don't think this is actually possible, but this is what the technology is trying to do. Who are the representatives of transhumanism? The representatives of transhumanism is not some kind of funny guy, Nick Bostrom in Oxford University, okay? These people that represent this idea are at the very leading edge of technological development in the world, okay? At the very top of particular fields. So one man is Rodney Brooks. He was born in 1954, so what would he be now? 66. So he produced 2003. He produced this book, Men and Machines. You can see it here about robotics, and you can see he has a screen, and he's put the eyes on the screen, so you can already see that you don't need to make a robot look like a human being. Why do they keep doing that? Yeah, but he already was doing that. Then Eric Drexler, MIT. Rodney Brooks, MIT, Hans Moravec, I already mentioned him, from Austria. He wrote this book, I, Robot, Mere Machine to Transcendent Mind, was very important in the movement. 20 years ago he published that. But you can see that these people, Carnegie Mellon, so these institutions, Massachusetts Institutes of Technology, MIT, you know, in France they have these Écoles Normales Supérieures, okay, which are above the universities. And the Massachusetts Institute of Technology is like Max Planck. So you're above the university. So you're at the very, very top, okay? And in these institutions, of course, you have an enormous interaction, government, industry, military, okay? So this is the level you're operating at. And these people are coming from the absolutely premium institutions. Here's Gregory Stack. He published this book, UCLA. Then James Hughes from Hartford, Connecticut. So you can see here in these books, the moral aspect is creeping into it now, okay? So here, using neurotechnology to become better people, choosing our genes, choosing our future. And then, of course, Richard Dawkins, he's not really part of this movement, but his ideas feed into it a little bit. And for example, this is a guy, he's from Oxford University, Aubrey De Gray, Ray Kurzweil, we already met him in this Wired magazine, and Yuval Harari, very important. Yuval Harari was closely connected to Angela Merkel. Yeah, genau. Yuval Harari, he wrote this book, Homo Deus, okay? And he was in the Bundeskanzleramt. He was in political Berlin for about a week. Very important a philosopher. So here are the two. So Aubrey De Gray, he wrote a book, Ending Aging, the rejuvenation breakthroughs that could reverse human aging in our lifetime. Now this is, of course, I don't think it's possible to reverse human aging, but these ideas are being, put out, or Homo Deus, a brief history of tomorrow. So you can see this almost, I would almost say, chiliastic, this desire to get beyond ourselves. So we're moving into religious territory now, okay? And it's, of course, part of the computer, part of popular culture. We get bombarded with these ideas the whole time. So what are the goals? And I'm not making this up, okay? These are what they write down in their own documents. So you can divide the goals of transhumanism into 3 steps: short-term, medium-term, long-term. So the short-term goals are to increase life expectancy, to increase intelligence, and to overcome the physical and psychological limits of human existence. Okay, those are the short-term goals. I would say those are pretty ambitious goals, okay? But those are just the short-term goals. The medium-term goals are to meld, so to mingle the human and the machine worlds, okay, at the physical level. So the idea is we used to have the TV set that was at home and the radio. So now we have the smartphone, and we carry that with us. And then the next thing is we start to wear it, okay, the watch, okay, or the glasses. Then we put it in, so we have the inside, the chip, okay, so that's the next thing. And then the idea is to closer and closer to merge the human and the machine. That's just the medium-term goal, all right? What's the long-term goal? The long-term goal is to mingle human consciousness with the machine after reaching what's called the singularity. We'll get onto that in a second. And to create a new species of individuals called extropians. Okay? So the idea is to create a completely new type of species. Okay? Of I don't know what you'd call it, not animal, but that's the idea. And then, like in the Borg, to be able to mingle all of the different individual consciousnesses into one consciousness, like a hive mind. That's the idea. And then ultimately to achieve immortality. Right? Now, so this is from the book Countdown. This is from Ray Kurzweil's book. It's Countdown to Singularity. So you can see here, that's a logarithmic scale, time to event, and this is time before the present. And you can see we start off with the emergence of life. That's about 3 billion years ago. Then eukaryotic cells, Cambrian expansion, and so on and so on. So then we get human ancestors, spoken language, writing, printing, industrial revolution, personal computer. So what you can see here is a straight line, okay? And the idea is fairly simple. So green is the sum total of human intellect, okay, of human intelligence. So human intelligence is essentially dependent on the number of humans. So the more, thank you, the more humans there are, the more the collective intelligence is. So that increases, but the machine intelligence starts in 1950 and increases exponentially. And the point at which the sum total of machine intelligence exceeds the sum total of human intelligence, that's called the singularity. Okay? It's almost a religious term. And after that, the humans then begin to fall behind. Okay? Because the humans can't keep up. So the machines then begin to improve themselves and separate from the humans that cannot improve themselves or who do not take part in this. And there have even been schemes that the remaining humans who don't take the shot, okay, that they would be allowed to live on reservations like the Amish people today in the United States. And there's even a term for them, which is humanish, okay? So you can see here, this is us in the future. We're on the horse and cart, and this is it. So we're kind of in the way, but they just let us exist. So you might say to me that those are just completely crazy ideas, okay? Nobody could think that. Well, that's not actually true, because who you see, this is an article from the Mail, the English newspaper, the Mail, a year ago. So it's not that long ago. And you can see here Jeff Bezos. You know who Jeff Bezos is, okay? Amazon. And Yuri Milner. He's a Russian oligarch. So they're financing a company which is aimed at biologically reprogramming animals so that they can live forever. So of course, if your paradigm is a materialist paradigm, well, the obvious answer is that it doesn't end. Okay, so they are putting, and who do we meet here? Juan Carlos Ispizua Belmonte. He's the person we met with the chimeras. Okay, so he's part of this. Shinya Yamanaka, he's from the Nagauchi group that I introduced to you. So you can see these are the people who are involved in the chimeric research, and now they're involved in the startup. Here we can see that's Jeff Bezos, Yuri Milner. I always think that when they get to a certain age, when they shave their heads, they don't really want to get old, okay? So no, I've noticed this. It's as if, you know, I'm not going bald. I just shave my head, okay? But you can see here. These are the two. One species has been treated with this gene, okay? They've done genetic manipulation, and so this mouse is both mice are at the same age, but the mouse on the left-hand side isn't showing the signs of aging. So when a mouse, like human beings, when they get older, they get smaller. This happens to mice as well. The older mouse is then wizened, we would say in English, smaller, and the mouse that has been treated. So that's actually possible. You know, it is possible with genetic manipulation. It's also possible by semi-starvation to increase the lifespan of a mouse by about the factor of 2. But they're not interested in increasing the lifespan by a factor of 2. They want to increase it indefinitely, okay? And we know who this man is. He needs no introduction. And the fourth industrial revolution will affect the very essence of our human existence, okay? So this is our friend. Unfortunately, this is Pope Francis. His stance on transhumanism, unfortunately, is ambivalent. I have to say that. And this is a message, a video message, November 23rd of last year. So it's only a little while ago. And he said, the specificity of the human being and the whole of creation, our uniqueness vis-a-vis other animals, and even our relationship with machines are being questioned. Okay, so he's already our relationship with other animals, our relationship with machines. He says it straight out, okay? And he says, but we cannot confine ourselves just to denial and criticism, okay? We cannot confine ourselves to denial. I want to just show you this video. This is from Klaus Schwab, brought to us by Schwab and Friends.
The very idea of human being some sort of natural concept is really going to change.
Our bodies will be so high-tech, we won't be able to really distinguish between what's natural and what's artificial.
With the ability to visualize brain activity, for example, through a simple consumer-based EEG device, it gives us access to ourselves in ways that we've never before thought possible. It unlocks the black box that is the brain and enables us to really, truly be able to realize an identity that is aspirational. One of the things that I think is so essential to free and open societies is freedom of thought. And up until now, the conversation we've been having is around freedom of speech. Once we can access people's thoughts and access people's emotions, we have to create a space that enables people to think freely, to think divergent thoughts, to think creative thoughts.
So what she said was, you know, up to now we've only been able to access the spoken word or what people have written. But if we can access their thoughts, if we can access what they're actually thinking, we have to create spaces where they can think more freely and more creatively. Okay, so it's not to be able to, you know, to know what people are thinking. We don't want to supervise them, or we certainly don't want to be monitoring what they're thinking. We just want to create these spaces where they can be more creative and have better thoughts. Okay. I just briefly want to, because we're in the time of COVID, just want to show you a few little connections, if you know, joining the dots. So this man, Charles Lieber, he's a chemist and a nanotechnologist at Harvard University, okay? And he's in hot water right now because his area of interest is the interaction between living cells and what are called nanowires, which are very tiny wires made of graphene. So the idea is, I showed you this matrix where you have a three-dimensional artificial tissue with neurons living on it. And then you want to be able to access those with little nanowires. That's his area of expertise. And he was cooperating with the Wuhan University of Technology in China, working on this technology. And he got into trouble because he was taking money from the American government, and at the same time he received financial support from the People's Republic of China as part of their 1,000 Talents program. And the research he was doing actually is interesting because it was all being financed by the Ministry of Defense. So he was DARPA, so the Defense Advanced Research Projects Agency, Air Force Office of Scientific Research, Office of Naval Research, National Institutes of Health, we know who they are. So what we can see is he was truly part of this military-industrial complex, working on this technology, being funded by the American government and also taking money from the Chinese government, okay? And Elon Musk, you know him, founder of Tesla, founder of SpaceLink, another company of his is called Neuralink. And Neuralink is, he's interested in developing technology that will directly access the human brain. It's called neural lace technology. So he's a big proponent of this. Another proponent is not just Jeff Bezos, but also, for example, Peter Thiel, whom some of you might know. So Peter Thiel, he was involved in the start of Facebook, of Accenture. He was also connected with the campaign, with the Donald Trump campaign, as one of the very few people in Silicon Valley. And he's a big proponent. So these are the really big tech names that we have. And so current wealth, just as a point of reference, of Elon Musk is about $200 billion. Okay, $200 billion. So, and then we have this man here, Robert Langer, from MIT, nanopharmacology. He collaborated with our friend here, Charles Lieber, and developed artificial tissue lattices for monitoring the heart. So the artificial tissue lattices, Elon Musk. And Robert Langer is one of the founders of Moderna, okay, the vaccine company. And he has become a multimillionaire off the back of the Moderna vaccine, okay? So just for reference, this is a graphene nanowire, 10 angstrom units. So angstrom units is 1 atomic unit. So these are really very tiny structures. And so this group, we can see here this interaction without not being able to know exactly what it means, but I just wanted to show you that. And another thing is, for example, this is a booklet which came out last year, at the end of 2020, it's a year, just the end of, just about a year ago, from the British military. Okay, the Ministry of Defence, you can see it here, Human Augmentation, the Dawn of a New Paradigm. And who's the cooperation partner? You can see it here at the bottom, Bundeswehr Office for Defence Planning. Okay, so the German Bundeswehr and the British military are developing this document, and I just show you a few little pictures. It's almost like cartoons. They obviously they don't want to overload the military with the details. But one is here, so you can see here. So here's the person: physical, psychological, social. So physical is, for example, the exoskeleton. So you get the soldier wears a suit of armor essentially that enables them to have increased strength and increased stamina. And then you have psychological and physical sensory augmentation, tele-existence. So that would be a drone. So you're sitting, let's say, in Virginia, but you're driving a drone which is in let's say Saudi Arabia. Okay. Then you have genetic engineering in the middle, genetic engineering, bioinformatics, brain interfaces, pharmaceuticals. Okay? So this is the core. And then you have neurostimulation, augmented reality, social, which is actually where a lot is activity. They didn't put anything in that box. But a lot of it, of course, is this is of course psychological manipulation and so on. So this is part of their document. This is the example they show. So they say you start with glasses, then you have contact lenses, then you have laser surgery, binoculars, night vision, and then you start doing gene editing. So this is the CRISPR-Cas9 technology. So you start editing the genes of people to give them improved visual ability. This is directly from that book. So this is the Transhumanist Association. Okay, so you can see device, wearables, implant, and then so the British military and the Bundeswehr are completely on board with this. There's no other conclusion you can take. Okay. So what is transhumanism? Transhumanism is, for me, I call it a scientistic religion. We have to we have to distinguish, and particularly in the present time, we have to distinguish between science and scientism. Okay? Wissenschaft und Wissenschaftismus. Yeah? Scientism uses the language of science. So they talk about statistics, incidences, all of this. But it's actually got nothing to do with science. It's in fact the opposite of science. So science is founded in doubt. Scientism is founded in certainty. So science is founded in empirical evidence. Scientism is founded in belief. Okay, so it's a scientistic religion. And G.K. Chesterton, many of you will know this quote. He said, the first effect of not believing in God is not that you don't believe in anything, but you believe in everything. So once belief in God disappears, people don't stop believing, but die glauben in alles Mögliche. They believe in every possible thing, okay? And so transhumanism is not located in the realm of science. It's located in the realm of religion, okay? And there are a lot of other scientific religions, okay, or scientistic religions. So one scientistic religion is, for example, ecologism, I call it. So ecologism has various subsects. So one subsect of ecologism is veganism, okay, or climate hysteria, that would be a subsect, or animal rights extremism, or overpopulationism. These are all subsects of the scientific religion, ecologism. Or you have the scientific religion, economism. So you have the classic and the Marxist varieties, where the economy is everything, okay? Or the extreme neoliberalism is a scientific religion. Or you have then the whole scientific religion of structuralism. And the huge subsects of structuralism came from France, of course. So you have postmodernism, and gender theory. So those are subsects of the structuralist scientistic religion. And I think we need to understand that this is what this is why, of course, it's resistant to argument, because these are dogmatic religious tenets. And they're using the language of science, but it's only a smokescreen. It actually believes in things like immortality. And I just want to, so these are 3 books that Ray Kurzweil, who's essentially the guru of this movement, okay? So he started off 2000, the age, listen to the words, of spiritual machines, okay? And then we have here the singularity, 2006, the singularity is near, okay? And then 2010, living well forever, transcend. So it's obvious to me, certainly, that this is a more religious than a scientific. I'm going to close now just to bring us back to reality. Okay, how realistic are these ideas? In my view, they are completely unrealistic. So if we just look at the problem of the human mind, there are huge, big questions that have not been solved. Okay, so the first question is just simple questions. What are memories? What are long-term memories? Nobody knows that. Okay, how are long-term memories stored? We don't know. Where are they stored? We have no idea. So a person, there have been lots of experiments done where somebody has had an accident or a stroke or a tumor and they lose a part of their brain. Well, they don't forget half of what they know. And you could do a kind of a thought experiment. You remove one half of the brain. The person may have word-finding difficulties, may have difficulties in moving, but they won't forget half what they know. And then you put the half back in, and then you remove the other half. And they still haven't forgotten everything. So the question is, where is it? It wasn't in the first half, and it wasn't in the second half, so where was it? The question is, we don't know where it is. So where are memories stored? What is consciousness? What is consciousness? What is this? What is the internal screen on which our existence? We have no idea, right? This is actually called one of the hard problems in science, the mind-brain problem. Okay, it's a hard problem. Is consciousness is mind purely a product of brain? Is consciousness a product of the brain? Or is the brain alone responsible for consciousness? Or is it the entire nervous system? So there are indications that, for example, the heart has its own nervous system. There may be a certain element of consciousness located within the heart, or even in the digest. We don't know. So is it the entire nervous system? Or is consciousness related to factors outside the body? So is consciousness, is the brain like a radio receiver? So if you have a television set and you pull the plug out of the wall, okay, the picture will go off, but the picture isn't coming through the wire, right? The picture is just giving energy to the receiver, and the picture is coming from outer space, from a satellite, let's say. So if you alter consciousness, well, you're just kind of fiddling with the buttons on the television set. But where the actual, we have no idea about that. Okay? I mean, I have, of course, I have my own particular view on it, but from a scientific perspective, we have absolutely no answer to that. Okay? So what they have said, a few years ago, there was what was called in artificial intelligence the phenomenological turn. So man hat gesagt, okay, consciousness, we can't really solve consciousness, but we will work on intelligence, like Rechenkraft. And if we have just enough of that, by brute force, consciousness is an emergent property that will emerge out of this computing power. But there's no evidence for that. This man, Hubert Lederer Dreyfus, he died in 2017. Already in this book, 1979, What Computers Can't Do, The Limits of Artificial Intelligence, he set out the limits and showed quite convincingly that this is it's not just a problem that we can't solve now. It's a problem that cannot be solved. We cannot achieve immortality. We cannot mimic consciousness in a machine. We cannot mimic memories. Why? Because we don't know what these things are. So, and Dreyfus showed this. He was, of course, he's completely. If you say the name later as a Dreyfus to AI people, they make that sound. Oh no! So it can't so das wie Vampire. Können wir gar nicht haben. So, but aber das ist, he already, 1979, so it was clear, fairly early on, once people started going into the theories of this, but this is now, we're now 40 years later, and the efforts are even stronger. And I want to just quote something that Stefan Reder said a few years ago at a talk in Berlin, and he said, the danger, he was talking about transhumanism, and he said, how dangerous is transhumanism? And he said, the dangerousness of an idea does not depend on how much it corresponds to reality, but purely on the extent to which its proponents are prepared to go in order to implement it. All right? So if we think back, for example, to communism, all right? And so at the start of communism, the Ukraine, of course, was the breadbasket of the entire region. And initially, at the start of communism, the farmers got their land back, and they supported the revolution. And then Lenin said, well, that's fine, but you have to give up your grain to the proletariat in the city. That's your function. And the farmers said, that's no problem. Just pay us and we give you the grain. And Lenin said, no, you don't pay, you donate it, because it's part of the revolution. So the farmers said, well, you're not getting any grain. So the soldiers came and the farmers hid the grain. So the soldiers then tortured a few, found the grain, confiscated the grain. Okay? So the next thing, the soldiers came and the farmers burnt the grain rather than give it up for free. And that's where then the whole program of kulakization started. And there was this, of course, you have to say, genocide in the Ukraine, the Holodomor. I think about 5 million, I think it is, died in the Holodomor. There are only 3 or 4 photographs. It was only admitted to, I think, by Brezhnev or Gorbachev. Gorbachev, glaube ich, no? Auf jeden Fall very, very late, okay? And millions of people died in one of the most fertile regions in the world. So the idea that the problem that an idea does not correspond to reality, particularly when you're dealing with highly intelligent people, they will then say to you, well, then we have to change reality because we have the wrong people. It's not working. We will redouble our efforts. Okay? Wir wollen die Anstrengungen verdoppeln. We will redouble our efforts. And we will, so the danger of this is not, and we have seen this in the last 2 years, by the way. So it's not the better argument. It's not, because it's not a scientific question. It's a scientistic question. And I made up the slide a few. It's called, I call it the continuity of deformity. Okay, so we have the human. This is Leonardo da Vinci, Vitruvius Man. So the classic view of man. Okay, classic proportions from Greece up to the start of the Renaissance. So here we have, and so we have one continuity. We become machine, transhumanism, synthetic life feeds into that. So we want to be like gods. We want to be like gods. But if we can't be like gods, well, then we go the other route. Okay? And if we can't become gods, then let us just be animals. So it's a continuity. I call it the continuity of deformity. Okay? And a part of that is what we see now. We see a relative shift in importance between man and nature. So this used to be balanced. But what we can see now, the rights of animals, the rights of nature have precedence, and man is becoming seen more and more as a problem. So not only are we the same as animals, we are now the problem, right? And there is a future. This has been already, this is Brave New World, 1949, Brave New World, 1932, 1984, written, of course, in 1949, published by George Orwell. Those are the two visions, the hard vision, the soft vision, okay? And you can see it here. In the one area, you have the hard, the state, right, the repressive state, control of information, and then the other hand, of course, the drugs, the various medication, entertainment, and so on. So what we actually have, you know, I think what we're moving towards is a sort of, we have the Orwellian, the steel Orwellian fist in the Huxleyan velvet glove. Okay, so the glove is, but inside the fist is made out of steel. Make no mistake about that. Okay, and just a book that just came out very recently, about 8 or 10 weeks ago, here by Norbert Hering, Endspiel des Kapitalismus. I thought it was quite interesting because he takes up a lot of these ideas, and I think, you know, what we are essentially moving towards, it's my view, is this is part of a bigger movement. I think towards, I call it a techno-feudalist society. So we have a huge discrepancy in power and wealth between, but we have a small group of essentially technical oligarchs, you would have to say, and then the mass of the population. So it has much more in common with a feudalistic society, but even we were talking about this last night, in a feudalistic society it was like a pyramid. But we don't have the pyramid. We have the top and then just everybody else. And the whole part with the transhumanist movement, the whole biomedical stuff, it's all part of this to essentially dislocate people from the center of the universe and to relativize their importance. So I think it's quite important. There's also part of this whole scientistic idea is very strong in this movement. Okay, and that's what I wanted to say today. Thanks very much.